Good afternoon. My name is Zhou, and from the Department of Electrical Engineering and Computer Science. Before I say any crazy scientific names, let me ask you a question first. Why is your phone on fire? Sometimes you find that your phone is warm and your battery level is dropping fast, even though you're not using it intensively. Or sometimes you find your laptop is so hot that you can fry an egg on it. These phenomena are called overheating. As part of my research today, I'd like to talk about two questions. One is what is causing overheating? The second is what can we do in order to reduce the overheating? In order to answer these two questions, let's take a closer look at the phone. Inside the phone, all the information and the data are stored as binary numbers, namely a bunch of zeros and ones. Physically, these zeros and ones are represented by MOSFETs, which are based on silicon. There are billions of MOSFETs in one phone. To understand how one MOSFET works, help us to understand what is causing the overheating problem and probably figure out how to fix it. You might not be familiar with MOSFETs, but probably you try to use a hose to transfer water from one bucket to another. And that's similar to a MOSFET. In a MOSFET, we transfer electrons from the source bucket to the drain bucket from the channel. If you recall, the key step to transfer water is to suck out the air inside the hose and fill it with water, because air blocks the flow of water. Similarly, in a MOSFET, we can control the gate to either empty the channel or fill it with electrons. If we fill the channel with electrons, there is a current flow through the channel from the source to the drain. The real design is much more complex than two buckets in a channel, of course, but let's mark it as state one if there is current in the channel. On the contrary, if we empty the channel, there is no current in the channel, we mark it as state zero. This is a simplified picture of how MOSFETs can represent binary numbers. But how is this related to the overheating problem? Well, the current in the channel generates heat. If there is current in the channel, which is the active state, the MOSFET will consume power from the battery and generates heat. But in the sleep state, when you don't have current in the channel, the MOSFET should not consume power and there's no heat generated. With the development of technology, we want to make this MOSFET smaller and smaller so that we can have more MOSFETs in one phone in order to make phones with higher capacity and better performance. But the problem is, if the channel length is too small, the source and the drain buckets are very close to each other. In the sleep state, even though we empty the channel to prevent current flow, electrons start to leak from one bucket to the other. As a result, there exists a leakage current, and the leakage current generates extra heat. Ideally, in the sleep state, the MOSFET should generate no heat at all, like 20 years ago when the MOSFET was 100 times larger. But in fact, now it generates just as much heat as that in the active state. So the leakage current is one of the major causes of overheating. It wastes almost half of your battery power and transforms it into heat. So overheating is a problem. It's a bad thing. But how can we reduce it? We know that leakage current generates extra heat. What if we can stop the leakage current in the channel? then we can reduce the overheating. Obviously, by only emptying the channel, it won't do the job. We need to use something else to block the channel so that there will be no leakage current. And this is where my research comes in. I study the electronic properties of alternative semiconductor materials other than silicon in order to make the next generation of electronics. One material we study is aluminum arsenide. What's interesting about this material is that we found there are not only one, but two types of electrons in this material, which is X electron and Y electrons. What if we use one type of electron, for example, X electron, to conduct the current, and use the other type of electron to block the channel? Then we can get rid of the leakage current. Let's see how it works. So let's replace the original electrons with X electrons and replace the rock with Y electrons. Let's look at the channel. For the active state, everything's the same. X electrons can still flow from the source bucket to the drain bucket. But for the sleep state, instead of being empty, the channel now is filled with Y electrons. Just as the hose can contain a certain amount of water, the channel can only hold a certain amount of electrons. And now all the Y electrons have taken all the places. So X electron cannot go through the channel anymore, and now there's no leakage current. But naturally, X and Y electrons are all mixed together. How can we separate them and keep them in positions where they should be? We need to create filters that can only let one type of electron go through and block the other type of electron. And the way we could realize these filters is through string. You may know that materials expand if it's hot and shrink if it's cold. And different materials expand and shrink differently. If we deposit metal films on top of the aluminum arsenide, there will be strain induced because metal and aluminum arsenide shrink differently. As a result, if we carefully design the composition of metal, the orientation of the metal film, and the structure of aluminum arsenide, we can use strain to filter X and Y electrons. As shown here, a mix of X and Y electrons enters, but only one type of electron can get through. And these are the filters we need in order to block the leakage current. So now if we place two filters that only let X electrons go through at the end of the channels, for the active state, again, X electrons can go through, and there will be current in the channel because the filters are the friends. But for the sleep state, since the filters can only let X electrons go through, all the Y electrons are trapped in the channel. And because all the Y electrons are standing in the way, X electrons cannot get through. And now the channel is blocked, and there's no leakage current. And we know that leakage current creates extra heat. And since now we get rid of the leakage current, we can reduce the overheating. So we learned that your phone is on fire because leakage current generates extra heat and causes overheating. And by using the two types of electrons in aluminum arsenide, which can be controlled via strain, we hope that our new design of electronics can be one of the solutions for the future. Thank you very much.